For today's webinar, we are going to cover a medical part. So with that, we'll go ahead and just jump right in today. So here is this medical part, and this is a probe that goes on a sonogram machine to be able to take biopsies. It's a specialty part, and there are a million variations of these parts for different types of probes and stuff. So this is an interesting example of a medical part that medical companies need to reverse engineer because they have lots of legacy designs that they've created throughout the years, and there are reasons why certain probes may work better. Certain doctors like certain kinds or brands or like specific designs for a whole host of different reasons. And as I was looking up this part, there were thousands of different variations of this kind of part here. So this is a great candidate for scanning, is really what I'm saying, for the medical world. Again, medical is amazing, and we have so many different applications within the medical world. And a lot of it's focused on anatomy, but some of it is purely focused on the equipment itself, like in this instance here. So with that, we'll go ahead and jump in to the DesignX portion where we roll back through the history tree. And as I do, I explain the process of reverse engineering this part. So let's go ahead and get started. So as usual, we always start out by just going over this slide, and I will pare it down. As a lot of people are watching my webinar on a regular basis, I know that going over this slide could take a few minutes, and it's redundant for you, but I just wanted to make sure that anybody that's watching this for the first time understands what DesignX is really quick before we dive into the application. But DesignX is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners even, all kinds of different devices. We're creating this type of data, and people were trying to load it inside of CAD, and we're struggling a lot because CAD wasn't designed for this type of information. Enter DesignX. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right-hand side, whether these are the high-level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this DesignX product is all about. Grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the DesignX portion. So here is the part. As usual, I tend to show the final solution here before we dive in and roll back through the history tree. So there she is. Awesome. So now if I just go ahead and roll back, and roll forward. We'll start off, looks like we start off with a loft wizard there. Turn on the mesh. So we go ahead and do a loft wizard on the inside, and then we do a extend to extend that a little bit further out, farther out, and then looks like we do a loft wizard on the inside ear. Now what you're going to see, what I like to call this approach is obviously this is a surfacing approach that they're taking, and it's an inside outside type is kind of what I call it or whatever. So we're going to model all the inner surfaces on this side and then all the outer surfaces and then stitch it all together is the general approach here. So it does help to have some sort of ordered fashion and as to how you're breaking down the part. So they're going to model all the interior pieces with, because this mates with a probe, and then all the exterior pieces too. So they went ahead and did an extrude wizard here. And then we're going to do some trim all that together. Very fillet cleanup there. Looks good so far. And then the other thing is modeling half of it and mirroring it across is obviously what's going to happen too. Now we went ahead and did extrude surface there. And then there's another, because it has like a little, if I just hide the surfaces there and then turn them back on, you'll see where we go with this here. Because it has a slight angle to it there. You can see it on this side here. So we trim those two together. We're going to do a couple more extrudes. Extrude this section, and then this part is going to cap it off, and then trim those to each other, and then trim all of that into that surface. So you see here we have that bottom surface and then the side ear there. Now, let's just open that one, just because a lot happened all at once there. And let's open up the first one. Let's open up this one. So they extruded this through and then trimmed it with the surrounding surface. And then trim that in with this too. Lots of trimming. And then we go back and add our fillets. So as you can tell, like fillet cleanup, fillets, you can add those to final sub assembly. You know what I mean? This is kind of like a sub-modeled area that's going to trim in with this main piece as you break it down into separate pieces. The reason why I bring this up is sometimes people will try to leave all the fillets to the end, and then they struggle to try to fillet things together. And this is true for any CAD. If you've done some modeling, that trying to fillet things together, because fillets operate different in every single software, and so doing these fillets intermittently on final sub-assembly type, it's not the right term, but parts to, as you model sections of the model, then kind of come back and you see here, add fillets to it wherever you can. I tend to try to save them to the end as well, but it just depends on the part when you kind of come in and add those. So you see here, we're trimming all this. Couple more extrudes. So now we're going to come down the side. And we're going to trim the back here. So if I just turn the surfaces off for a second, you see here. So we kind of, I think we're transitioning now from the inside to the outside. And now we're going to start trimming these pieces together here. So this one we applied the fillet to the tool first. This happens as well. Sometimes I might try to save the fillet and apply it later, but in this instance we're applying it to the tool that we're going to trim. And they fit aloft to this outer shape here all the way down. The whole outside ear all the way. And then we'll go ahead and trim. So just to give I hid the inside. Now we're on the outside. And you see what we're doing here. We fit that main line down the side, and we're going to trim all of this and model all those sections here. I did another loft fit for that different angle there. And we're going to cap it down and trim it. And then now you see that we trim the inside with the outside. And it looks like we're going to do some fillet cleanup work by filleting all of the boundary all the way around the outside. Now we will do another extrude and trim. So we extruded a surface down the middle, turn the polygon off. And you see we're on the home stretch as far as the shape is concerned. And then we did a delete face. Now that is over here. So right before we did the delete face, you see it's accurate, but it's just kind of wonky. So what they did is they deleted the face, extended the surface. Actually, you didn't even probably have to do that. Then we drew curves on the surface. This is a favorite method here. Then we do a split face, delete that face. So you're trimming it back to make a cleaner surface there. And then a loft between it and sew it in to get a nice clean transitional surface there. Now we are going to mirror it across, loft the inner and the outer, and stitch it or sew it. Sometimes I keep using a SolidWorks term for that. And after that, we're going to loft the pieces together and sew them too. You see we still have a little piece down there. So we're going to loft, sew. Boom. And as soon as we sew it and it's a bounded shape, it becomes a solid there. Then we come in and we add some fillets, filet mignons. And then let's see where we go here. I think there's some cleanup work that still needs to be done. On this back side, that's what was going on here, is cutting this piece out, adding the fillets, cutting those pockets away and chamfering those, adding fillets to the chamfers, and then filleting the rest of that. Cutting the hole in the end here. And then you see here there's some connection areas, some pockets that we need to cut out. So there's one of them, and then here's the other one. Cut a pocket out there. So there is a surface modeling example. Now there were a few different things that happened in here that were really interesting that I wanted to highlight. one of them is when you're doing sketches, we'll just go ahead and open up, just collapse this and turn on my planes. I know some people love it when I have these planes showing all the time, so sometimes I hide them. You know, some people out there. But here we go. I'll take this plane and then I'll sketch on it. And I just wanted to highlight a piece of functionality. I got a question about this the other day. Is sometimes I will draw a sketch, and this sketch might be something that I'm going to loft between another segment here. And let's just make it like a 3. I'm just randomly drawing here. 3 lines. Then we'll click and drag and add some fillets. So you have this, and then I'm holding control. If you hold control, that's a shortcut. When you roll over a plane and hold control, you can offset a plane, which is really handy. And then now if I come over here, I'm just going to do, I'll just do 2 line segments and 1 fillet. And now, if you go to loft these, anybody that's done some lofting, you see that it's not too bad. In this instance, it's going to do a reasonable job. But sometimes the line segments don't match up well to loft and make a nice clean loft. So we'll go ahead and accept this. And this is an okay one. I could have made it a messier loft by doing more segments and less segments on each side and not having them translate over well. So we'll go ahead and undo that. But one thing that you can do to mitigate these dirty lofts by having different line segments inside DesignX is to come over here and I can edit this sketch, normal 2, and then you'll see that we have this tool right here called Convert to Spline. And we'll just take forever clicking on all these. And then really tight fit tolerance. We're going to convert that to 1 single spline. So now when we roll over, it's going to be 1 object here. Now we'll come over to this, do the same thing. And you can also select remove original entities. So what we're going to do is we're going to fit a spline over top of it, but yet keep that. So it's going to be a spline and line arcs in there. Now, when I go to loft, I can roll over the spline and roll over the spline. And you see I get a nice clean. Now, you can also control that even more by coming over. Let's double click on the spline, and make sure the spline has, okay, it has 44. Let's just make it 50 nodes. So it's going to redo the nodes on that spline so it has 50. And then this one, I roll over it. It's only got 32. Let's make it 50 so it's nice even. And then it'll make it even smoother. So we have a cleaner lofted surface. So that's something that I wanted to point out, that when you're doing these lofts, that you have that ability to draw it as a line arc sketch and dimension it out with the convenience of line arcs, then convert over to splines and keep the line arc geometry if you need to, and then convert them to splines, and then once they're splines, give them the same amount of numbered nodes, then loft it together, and your lofts will thank you. So that is a really valuable. So on a surface modeling project, a lot like this one right here, that is a very valuable aspect to be able to use that tool. And that came up. I had a customer asking about this week. He had issues with his lofts, and this was the solution, is to go in and convert them, and it solved the problem. Very easy and quick solution there. Now, another one that I wanted to bring up here as we hide this, let's just come on in and just create some basic geometry. Extrude it. Just give it a little more length there. Hit OK. Now we're going to turn on our solid. And you see one mistake I did is in the newest version here, sometimes it has merge by default on there, which is a lot like what SolidWorks does. So it merged it with it, and I didn't want it to do that. This is a fillet question, very interesting fillet question that I discovered. I have to admit, I did not know that this tool was inside of DesignX. I'm embarrassed to admit this was interesting to me. So what you can do here is I'm going to do a 3D sketch, and I'm just going to draw an arc here. So I drew an arc there. Get out of it. I'm going to come over to fillet, and you can grab your fillet and you can type in, there's your fillet. Awesome. But if you clear out this and you do a full face fillet, I mean not full face, but just a face fillet, and clear that out because I clicked on the wrong. I just want one. I just want the other. And you see here, I got a 15. I have a 15 millimeter fillet going on. You can actually say hold line, and I can click that hold line, and then I can come over, and let's just click these again. What's going on here? And I can type this up to like 50. And I finally got it correct here. So the picking is just not treating me well today. So if I just make the fillet dimension bigger than this dimension actually is, look at what it does. So I can use this like guide curve within the fillet to create this variable fillet and hit accept, as opposed to using a variable fillet, right? This is kind of my concept here. Now I want to see something real quick. This is just kind of on the fly. I'm going to come over here. We're going to put a sketch on. I want to see if we can use a 2D sketch to do the same thing. So if let's just combine what we've learned today. Kind of didn't want to do that, but whatever. All right, so I'm just thinking here. Yeah, let's do this. And I don't need this. And I'll just trim this off. I could convert entities. There's like lots of different ways you could go about doing this, but let's try it this way here. Just thinking out loud here. Let's apply that. I'm going to try it as line arc first. So we're going to do a face fillet from here to there with the hold line. Yeah, so it'll do 2D sketches as well, as basically what I was thinking. Doesn't have to just be a 3D sketch. So really neat concept of, if you can draw out these hold lines, that could be an interesting way of creating these fillets. So there's some free ones there for you. Now, what I wanted to do also is just highlight another workflow within the DesignX paradigm as well. It's a little bit off topic here. So one thing that I get a question about is the live transfer functionality. So if I just come over here and I grab this part, and people, normally the workflow that we show often on this webinar is I either model everything in here and save it out as a step file to go manufacture it. That happens quite often. I model everything in here and live transfer it over. So that's another workflow that is a popular workflow in here. But then there's this third one that I have quite a few customers that also do too, to where they actually don't model everything in here. They just come in, for example, and they'll select this and they'll say, let's do a mesh sketch. They'll come down, and you can even silhouette this. Let's just silhouette the whole part there. And we'll turn our mesh off, and we'll come over to this rectangle tool and check this rectangle tool out. We added this a few years ago, where I can best fit the lines based on a selection of all four sides here, and I can just keep adding to it, you see, and it will fit. And then when I'm done, I can accept it, and we're done. We're out. So now we have the mesh. And then if I need to, I can come over here also and, silhouette this in the other direction. And come in and maybe draw a line horizontal and snap it there. Snap it over here somewheres. And same thing with this. You'll see that what I end up doing here is I kind of use this as a, and I like the way we have this resize tool in here. The resize tool inside of DesignX is neat. You can just click and drag instead of like trying to trim and extend using tools, like drawing a line out here and extending up to it. Resize, I can just click and drag it, and it will keep the normal direction of the line. So now you see here that I drew a horizontal, I drew these verticals. And then I just come over and I say, I want to live transfer that to SolidWorks, start from first feature. And I'm just going to toggle over to, I'll just hit it and then toggle over to SolidWorks. So you see that? And I can just say, hey, I want to extrude it. So what the workflow I'm showing here is, let's just say that I have something that I want to model, and I can say up to vertex. So I just want to say extrude it in that direction up to that vertex. And then the other line I just used as a reference to extrude farther, and then hit OK. So now you see that I extruded that. And so what I did is I just cut some sketches. I hit send over. And then now I can just toggle back over here and say, you know, this top surface, let's go ahead, create a region out of that. I just created another region. Oh, goody. So now I will click on that. Let's just say we want to do a loft wizard to it. And this happens with DesignX, by the way. I did by curve last time, and you're like, hey, what's going on? You have to remember to toggle back over to plane. Otherwise, you'll look at it and you get some like very interesting results there. That's all. So you can come in here and click on that, and you can see I can resize. And I am not doing a good job today here. So I'm going to hit next. I'm going to say surface insert with 2D sketches. Next. Next. There we go. We got next coming for us. And we will calculate that surface. It gives us a preview as normal. And then I can just say like 15 nodes. Hit OK. And then from there, I could just click the next spot on, because I did 2 sketches. So now I can just come over here, resume from plane 1, hit send. And you'll see that it's building those 2D sketches in, and it creates a loft for me, and it says export succeeded. And then, you know, you just use your regular surface modeling stuff over here, where I say I want to cut with surface and flippy flip. Hide it. And there we go. Hide all my planes. Hide all my sketches. So there we are so far. And now I'll just toggle back over. And some people, you may be asking yourself, Greg, why are you doing this way? And I'm just kind of laying this out for you. That on complicated parts, I have customers that do it this way. This is a compatible workflow that people use every day. So like that's really what is just pointing out here, is that I can say, hey, let's do this as a solid cut. Solid insert cut. So for right now, we'll just do it as a solid insert. So in this instance, because I didn't model the solid part, I just fit that. It's not letting me obviously do the cut. So I can just say, actually, you know what I could do? Surface insert and hit next. There we go. That's more like it. So it's just going to fit that. Now let's go back, and you can say custom direction, make sure it squares it to that plane. And then you see, because it recalculated with a different direction, I can just adjust the resolution, the sewing tolerance. and let it calculate again. Just drag it over. There we go. Hit OK. So it fit it as a surface. Now I don't have to send it as a surface. What I can do is I can click this and say SolidWorks send only selected entities. Send. So you see here that it sent this. Now I can just come in here. Again, you're asking yourself, why is he doing it this way? There are instances where if you're trying to do a very complicated model where you know that some of the stuff, the way it's going to translate over with live transfer is going to be a little challenging, you can do it this way to where you, there we go, where you model as you go. That's basically what this is I'm going to model as I go. And we will flip the direction. Let me just undo that. Let's just cancel out, undo. There we go. And do that one more time. Hit OK. So the idea again is if it's going to be a lot of steps to live transfer, a lot of things to fix during the live transfer, is you may do this parallel modeling workflow where I model or I extract and send and extract and send over to the CAD package to model. This is a valid workflow. And then with this workflow, there's no like live transfer at the end. I send it as I went, and I can, if I have dual screens, I'm just send model, and I keep going. And when I'm done with this, I can actually save this out. Just save the SolidWorks file, load the SolidWorks file back in to DesignX and do a 3D comparison if I need to compare to the CAD. So this is kind of like a hybrid live transfer workflow. And this is the method that I would use for DesignX Go, and plus the majority of the time, by the way, trying to model complicated things. If it was a complicated part, I might do it this way. So I just wanted to highlight that this workflow exists. This is a style of workflow that I don't always point out, and the topic came up around our water cooler the other day. This workflow is a very valid workflow. It does a great job, and sometimes people forget about it and we don't highlight it enough. So I wanted to bring it up here at the end of this webinar.